All right, today we're going to play detective and crack a really tough case in the world of AI. Think of it like a mystery. It's got hidden clues, some pretty expensive problems, and this really clever technique that lets AI see the world a bit more like we do. So let's get right into it. So the mystery really starts with this number right here, 20%. Get this. In the US healthcare system, a staggering 20% of all insurance claims get rejected right off the bat. That's 1 out of every 5. And look, this isn't just some small snag in the system. We're talking about a multi-billion-dollar headache that creates a total mess for pretty much everyone involved. Hospitals, insurance companies, and yeah, even patients. Which, brings us to the big question, right? We're living in the age of big data. I mean, these healthcare companies are practically drowning in information. Patient records, billing codes, you name it. So if we have all this data right there, why on earth is this huge, expensive problem still happening? Well, the answer is pretty simple, actually. Raw data by itself, it's basically like a messy crime scene. All the evidence might be there, but it's all over the place, it's disconnected, and it definitely doesn't tell you the whole story. To really solve the case, you need a detective, someone who knows how to spot the important clues and actually put them all together. Okay, so let's take a closer look at the scene of the crime. Because this isn't just some one-off thing. It's a huge mystery, and it has some really serious consequences. You see, just one single rejected claim sets off this massive ripple effect. Financially, payments get held up, and the admin costs just go through the roof. Operationally, it's a nightmare. Staff get stuck in this super slow, manual loop trying to fix everything. And for patients, it can mean really frustrating delays in getting the care they need. On top of all that, if the organization doesn't figure out why this is happening, they could be facing serious compliance risks. It's just a massive, massive drain on the whole system.
But here's a thought. What if you could actually predict which claims were going to get rejected before you even hit submit? Well, that's exactly where our data detective comes in. They've got a really powerful technique for finding those hidden clues.
And that technique is called feature engineering. So what is it? Well, you can think of it as both an art and a science. It's all about taking that raw, messy data and transforming it into meaningful signals. We call them features that an AI can actually make sense of. And the key thing here is, it's not about finding more data. It's about making the data you already have way, way smarter. And this slide just shows you that transformation perfectly. On the left, you've got the raw data, the crime scene. A computer sees a start date and doesn't know what to do with it. But if you combine it with the total bill, you get something powerful, a real clue. Cost per day. See the difference? A patient's birth date is just a fact, but a patient risk score, now that tells a story. That right there is what feature engineering is all about, turning these random data points into clues that actually mean something. So how does our data detective actually find these clues? Well, it's not random. There's a real systematic process they follow. The whole investigation really breaks down into 4 main steps. First, you've got to create new leads. This is where you combine data points you already have to create brand new insights. Then you change your perspective, maybe apply some math to see the evidence in a totally new way. After that, you extract key details, pulling out the most important bits from all the noise. And finally, you focus on the top suspects. This means you pick only the most predictive features, the ones that are really going to help you build a strong case. Here's a perfect example of that first step, creating a new lead. Look, a claim for $3,200 doesn't tell you much on its own. A 3-day hospital stay, same thing. But what happens when you combine them? Bam! You get cost per day, over $1,000. Now, that new feature is way more likely to tell you if a claim needs a second look than either of those original pieces of data by themselves. It's all about adding context. And of course, our data detective isn't just doing this one time. They do this again and again and again, creating dozens, maybe even hundreds of these new clues. And as all these clues start to pile up, the real story of why claims are being rejected finally starts to become clear. All right, so this is where it all comes together. This is the payoff. What happens when you arm your AI model with all of these smart new clues? Well, the results are, honestly, they're pretty dramatic. Before all this detective work, a standard AI model might be, 65% accurate at predicting rejections? I mean, that's okay, but it's not great. But after you feed it all those new engineered features, the accuracy shoots up to 82%. That is a huge jump.
We're talking about millions of dollars saved and just an incredible amount of manual work that just goes away.
And with that kind of accuracy, you can suddenly do some really powerful things. You can flag high-risk claims in real time before they're even submitted. You can build dashboards that pinpoint exactly which providers or billing patterns are causing problems. You can even start automating fixes for common errors and let your human experts focus only on the truly tricky claims. It's like the mystery isn't just solved, the whole system actually gets fixed. You know, this whole case study really points to a much deeper truth about AI. It's not just about having the fanciest algorithm or the biggest pile of data.
There's this great quote from the source material that says it all, really. Effective feature engineering is all about balance. The clues you create have to be relevant. They have to work even when you have tons of data. And, this is so important, they have to be understandable. It's a real craft, a mix of technical skill and just knowing the subject inside and out.
And that, right there, is the biggest takeaway for me. In this whole new age of AI, feature engineering is where human expertise really truly shines. It's where a data scientist's intuition, their creativity, their deep understanding of an industry, that's what transforms a pile of raw, kind of dumb data into something with real predictive power. So that leaves us with one last question to think about. As our AI models get more and more powerful, more automated, is this kind of human detective work going to become less important? Or will that creative human insight become even more critical for solving the really big, complex problems of the future? Something to chew on. Thanks so much for joining me.